Hey there, this is Mr. Wilford, and I thought I would just go through Chapter 5, Section 1 with you here a little bit. And when we talk about um, Chapter 5, we're going to be talking about quadratics. And to start out in Section 1, we talk a little bit about using transformations to graph quadratic functions. And basically, your graphing calculator will help you quite a bit if you have a graphing calculator available or on the computer using the graphing calculator there. In this first section, we're just looking at different um, quadratic equations and shifting them around a little bit and using our graphing calculator to tell what's happening in each situation. So first of all, let's talk about the parent function for a quadratic function. It's the most basic kind of quadratic function that you can have. The parent function f of x equals x squared looks like this right here, and this is called a parabola. You can certainly graph this by plotting a bunch of points, plugging in a bunch of x's and getting out a bunch of y's. But you'll get something that looks like this. Now, some of the problems here, again, will suggest that you graph these by using a table. I would certainly not do that if you have a graphing calculator. I would just certainly plug this into your graphing calculator, and you can see here what the parabola should look like. We can also talk about these transformations um, of the parent function x squared. Again, using a graphing calculator, you can really tell what's happening here. Basically, you want to use some of these things in your book or in your notes. As far as the shifts go, there's a horizontal shift of h units when you add or subtract something to the x. You can see here it's going to move left or right. There's a vertical shift of k units if you add or subtract something to the whole function, and that's going to make it move up and down. Um, again, when you look at examples like this, you certainly can plug in the parent function y equals x squared, and then you can plug in each of these separate functions, and you should be able to tell the difference between the two. Here we have a blue one and a red one, and basically you want to just be able to explain the shift. So I'm moving it left 3 and up 1. Here I'm moving it to the right 2 and down 1. And so if you plug in these into your graphing calculator, just like you see it, you should be able to explain the shifts that are going on. We also have reflections, stretches, and compressions of quadratic functions. Again, feel free to take a look at this chart here. When you do a reflection, you are basically multiplying by a -1 to the x. And when you're doing a reflection across the x-axis, then you're multiplying by a -1 to the y. Here we have a vertical and horizontal stretch or compression. And again, you can kind of follow along with each one of these. Again, what I would suggest here is that, let me go back here a second, that as you go through this, that you're using your graphing calculator for each one of these, and you could see exactly what kind of shifts are going on. There is something we want to talk about as far as a certain point on the parabola, and that's called the vertex, and this is going to be the lowest or the highest point. And one form that your book talks a little bit about is the vertex form of a quadratic function. And you can actually get your vertex from this, and it's hk is where the vertex comes from. So if you see something like this, this is your h, that's your k, and that is the vertex of the parabola, h comma k. Again, graphing calculators help a lot when you're graphing these, and you can really tell where that vertex point is. It's the maximum or the minimum point. And then these are some of the problems that you're going to be working on. If you have any questions, please feel free to contact me anytime. Thanks.